Hi friends, today we are going to see a question of rotational mechanics. The question is as follows. A uniform solid cylinder of mass capital M and radius r rests on a slab of mass small m. So this is the slab of mass small m. This is the cylinder of mass capital M. The slab lies on a horizontal frictionless table. If a horizontal force F is applied to the slab, it accelerates and the cylinder rolls without slipping. Find the acceleration of the slab, acceleration of the cylinder with respect to slab and with respect to ground or table. So first of all, you have to see that this table and the slab, this is a frictionless surface, so there is not going to be any force of friction between these two surfaces. Now obviously there will be force of friction between this cylinder and the block, then only you are having rolling without slipping. Now the next question is, what will be the direction of force of friction between these two surfaces? Now how to determine the direction of friction? For that, what is friction? Friction is a force which opposes the relative motion between the surfaces or the impending relative motion. What do you mean by impending relative motion? Impending relative motion means that relative motion which is about to happen, which has not happened but would have happened had there been no force of friction. So in this case, how to find the direction of force of friction? Whenever you have a difficulty in finding the direction of force of friction, there is a very easy method. For the time being, you just assume that the surface where you have to find the force of friction, that is a frictionless surface. That is, there is no friction between these two surfaces. If there is no friction between these two surfaces, obviously there will be a relative motion. So find out that relative motion, then whatever is the direction of that relative motion, friction will be opposing that direction. So you will see in this case, so you see this force F is pulling the slab towards right. So if there is no force of friction between these two surfaces, what will happen? This cylinder will remain as it is, remain here, and this slab will move forward towards right direction. So now for finding relative motion, I will observe this cylinder sitting on this slab. If I am sitting on this slab, if I am sitting here, so what I will find? I will find that this slab is moving towards right. So if this slab is moving towards right, if I am sitting it on this slab, I will find that this cylinder is moving towards left. It is going in this direction. So this is the relative motion. This slab is going right and this cylinder is going in the left direction, in the backward direction. So what will be the direction of force of friction? Force of friction always opposes the relative motion. So on this cylinder is moving towards left with respect to this slab. So what will happen? Force of friction on this cylinder will be acting in right direction, in forward direction. Since it is acting in forward direction on this cylinder, it will be acting in backward direction on the slab. So this is a very easy method of finding the direction of force of friction. You just assume that these surfaces are frictionless. If these surfaces are frictionless, there will be a relative motion. Find the direction of that relative motion. Your force of friction will be opposing that direction of relative motion. So having found out now this direction of force of friction, let's now draw the free body diagram. So to draw the free body diagram, now let's say this is the free body diagram of the cylinder and of the block. Of the cylinder, you see this is N1 is the normal reaction force which will be acting because of this block. Capital Mj is the mass, the weight of the cylinder. Small f is the force of friction acting in right direction. This is my block, so N2 is the normal reaction, small mg is the weight of the block. Force of friction on the block will be acting in leftward direction or towards backward direction, and capital F is the force, external force which we are applying. AC is the acceleration of the cylinder and AB is the acceleration of the block. So let's now draw Having drawn this free body diagram, let's write the equation of motion. Obviously there is no acceleration in the vertical direction, so n1 is equal to capital mg and n2 is equal to small mg. So there is going to be no role of these n1 and n2 in these free body in these equations. First of all, this small f is equal to capital MAC. Why? Because you see, in horizontal direction, this force of friction is the only force acting on this cylinder. So this small f is equal to MAC. Now if you take the equation of rotational dynamics, that is the torque, and now you calculate the torque acting about this center. So the torque acting about this center of mass of the cylinder will be F, small f into R, is equal to ICM, that is a moment of inertia of an axis passing through center of mass, into alpha. Alpha is the angular acceleration, like this. This is the angular acceleration. So now ICM of cylinder is half mr square. So if I substitute it here, it will be F is equal to half mr alpha. So these are the equation of cylinder, the motion of cylinder. Now coming to equation of the block. Now what are the horizontal forces acting on block? Capital F is the force acting in right direction. Small f is the force of friction acting in backward direction. So F minus small f is equal to MAB. So this is the equation of motion of the block in horizontal direction. Now, is there any relation between the AC and AB? That we have to find out, and that relation we will get because of the condition that this cylinder is rolling without slipping on this block. So what will happen because of this condition? You see, this is my cylinder. This cylinder is rolling without slipping on this block. So if I find out what is ACB, now this equation, all of us know that AC is equal to AB plus ACB, that is acceleration of cylinder is equal to acceleration of block plus acceleration of cylinder with respect to block. Now our main goal is to find out ACB, that is what is the acceleration of cylinder with respect to block. Now you see, if I am sitting on this block, if I am sitting here, if I am sitting on this block, say here, then what I will find? I will find that okay, this cylinder is rolling without slipping, and rolling in which direction? For rolling motion we have to find out what is the torque. So only one force can produce the torque, and that force is this force of friction. So this force of friction is producing a torque in this direction. So this is the direction of alpha also. So this cylinder is rolling in this direction. Now if this cylinder is rolling in this direction, what will be the acceleration of the center of mass? If I am observing sitting on this block, it will be in this direction. So this is ACB. ACB is the acceleration of center of cylinder with respect to block. And what will be the magnitude and direction? ACB is equal to minus R alpha. This is the acceleration of the cylinder relative to the block. Why minus? Because we have taken AC in this direction, AB in this direction, and this ACB is in negative direction, in backward direction. Therefore this minus has come. And why it is equal to R alpha? This R alpha because this cylinder is rolling without slipping. So this is the condition, ACB is equal to R alpha. You might think that okay, this ACB is going backwards. So what is the force which is causing this motion? Because the only force which is visible in this diagram is force of friction acting in this direction. So how this ACB is going backward direction? That's very simple. If we are observing the motion of this cylinder sitting on this block, then what happens? This block is a non-inertial frame because this block itself is accelerating. So if I am observing the motion of this cylinder sitting on this block, a pseudo force acts on this cylinder, and what will be the magnitude of that pseudo force? That pseudo force will be acting like this, and magnitude will be capital M, because this is the mass of this cylinder, into AB, because B is the acceleration of the frame of reference, which in this case is block. So this MAB is the pseudo force which causes this cylinder to go in this direction, backward direction, with respect to B. So this is the frame of reference. Now you see this very simple. AC is equal to AB plus ACB. So I can write AC is equal to AB minus R alpha. So R alpha is equal to AB minus AC. Now if I substitute these equations in this, you will very easily get the answer. Now that we have written that this R alpha is equal to AB minus AC, so how to find out the equation? You see this, if you say concentrate here, what is here? This is that 2F is equal to capital M R alpha. Now I know that okay, F is equal to capital M AC, so I can write it here. It will become 2M AC is equal to M R alpha. So I can write R alpha is equal to 2AC. Now substituting this value of R alpha in this equation here, you will get R alpha is equal to AB minus AC is equal to 2AC. So I can write AB is equal to 3AC. So this is the relationship between AB and AC. Now after this, I will use that AC is equal to 1 by 3 AB, and I will use in this equation, the equation of the block which I had written, F minus small f is equal to MAB. Therefore F minus 1 by 3 MAB is equal to small MAB. Now after this is a simple algebra. You will find AB is equal to this thing, then AC is equal to 1 by 3rd AB, that is this thing, and ACB is equal to AC minus AB will be minus 2F by capital M plus 3M. You see this minus sign is coming because this ACB is going backward. If somebody asks to find alpha, then alpha will be ACB divided by R with the minus sign. So this alpha will be 2F by M plus 3M, small 3m divided by R. As we can easily see that from the force diagram also, it is evident that the torque and therefore alpha is in the counterclockwise direction. The only torque acting is in this direction. You may say that okay, there is a pseudo force also here, but this pseudo force acts through center of mass. So when I am writing this equation, Fr is equal to ICM alpha, even in a non-inertial frame, this pseudo force will not produce any torque. So this is the only force, the force of friction is the only force which is producing the required torque. So this F is producing a torque in this direction, anti-clockwise direction. So this alpha will be anti-clockwise direction. Thank you.